Using energy principles only, in capital letters, calculate the speed of the box at point Z over here. Okay, so whenever energy principles are mentioned, we have to look at either of these guys. This WNC is a great one because that means the work for a non-conservative force, which is exactly what we're dealing with here. So we can work with this, the change in kinetic energy plus the change in potential energy. So that's great. We can work with that. But one reason we don't have to work with that is because there is no potential energy, because this object is on the ground the whole time. So we don't necessarily need to work with that if we don't want to. The other option we can work with is our W net equals change in kinetic energy, because it is on the ground the whole time, which means there's only kinetic energy, which means we can just go ahead and plug this in as well. Okay, so we've just written it down and we're seeing that 6.1 helped us with 6.2 and 6.2 is helping us with 6.3, because the two forces that are contributing to the work done in the system is the applied force and the frictional force. We don't have to look at the normal force and gravitational force. There also aren't any other angles to work with, which means we just have two forces that we're working with. So W net means the resultant work done, which means we have to look at this formula up here and deal with the work done for the applied force and the work done for the frictional force. Once we have that, those two added up or subtracting from one another, considering they're going in different directions, will then equate to the W net. Okay, so we can just write WFA and W frictional force. And then delta EK means the change in kinetic energy, which means half mvf squared. That's our final velocity minus the half mvi squared.